So distance is how far something moves on a path. The path may have many changes in directions. This is a trundle wheel. Trundle wheel is used to measure distance. Every time it goes around in a circle, it will make a click. That click represents 1 meter. Allow me to demonstrate. I'm gonna start right before it makes that noise. Hold on. Right there, so let me get that right here. Let me get back here. Right there, okay, ready? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right there, so we'll stop right here when we do it. Okay, all right, so it was 11 you said? All right, so my distance, let's put distance equals 11 meters because it went around, clicked 11 times. And my assistant, what was the time for that?
That was 14.2 seconds.
14.2 seconds. All right, the average speed, S, is how far you go, which is D for distance, and how much time, which is T, down here in seconds. We measured those things. Let's come on over here. All right, so we said S is for speed. I'm gonna put that right here, and it equals distance, I said divided by time. This is too many words. Instead of distance, let's just call it D for distance like I have on my slide, and again, T, let's call it T for time. So speed equals distance divided by time. I'm just gonna go 11 meters divided by 14.2 seconds. Let me plug that in my calculator. Oops. 11 divided by 14.2. All right, hold up, here we go. Strength. All right, so equals, I've got a lot of numbers, so 0.77464. Okay, hold on. Way too many numbers. Let's round to this spot right here. So we're gonna ignore those ones. This 4 is less than 5, so we're gonna call this 0.77. My units over here up top were meters, and on the bottoms we have seconds. And again, we're gonna make that an S. We're lazy, okay? All right, so our answer is for how fast, the speed of how fast I was walking was 0.77 meters in 1 second. So we're gonna solve the equation that we already know for D and for T. Let's come on over here again. All right, so we're gonna work, so first let's solve for D. So I've got S equals D over T. We wanna get this by itself. So we wanna get T over here somehow. Right now it's division. If we wanna get rid of it, we have to do the opposite of division, which is multiplication. So multiply over here, which means we have to do the same thing on this side as this side, put T over here. These two cancel out. I'm left with D equals S times T. Boom. Now, what if I said you were gonna walk and it was gonna take you 10 seconds and we wanted to figure out the D? We already have the speed up here. Speed equals 0.77 meters per second. So over here, I'm just gonna insert those numbers. So my speed, like I said, was 0.77 meters per second. Do not forget your units. My T right here, 10 seconds. So I'm gonna multiply by 10 seconds. Do not forget your units. Now, before we do anything, let's make sure our units cancel out here and make sense. Distance is in meters. So that means that my units over here should cancel, so that I'm only left with meters. I've got seconds on top and on the bottom, so they cancel each other. Perfect. I'm left with meters. I'm gonna put that right here. If I plug this into my calculator, 0.77 times 10 will get me 7.7 equals 7.7. Boom, meters. Do not leave your number naked. There it is. Fantastic. That's for D. Now, I'm gonna solve the same equation for T. So come back on over here for me. All right, so again, we know S equals D over T. We're solving for T, this guy right here. If you want to solve for something on the bottom, you can flip these two numbers, exchange them, and it will always work. It will always be equal. So I go like this, t here, s goes on the bottom, d stays on the top. Again, I put the s and the t and I flip them. T's up here, s is here. I know, oh, here we go. So we're trying to find t. I know my distance is 50 meters this time. 50 meters. Wow, it's a lot longer than before, okay? So I'm gonna put 50 meters on the top, 50 meters, and at the bottom, again, my speed was 0.77 meters per second. Now let's go ahead and take a look at our units first. So because this is dividing, our units really look like this. They're really gonna flip. So it's really gonna be seconds over meters. In that case, our meters, they cancel because we're dividing. We multiply by the reciprocal, and you're left with seconds. Does that work for us? Time is seconds? Yeah. Okay, so seconds here. Now for the easy part. 50 divided by, messed up, 7 point, I messed up again. Good thing I got that delete button. 0.77 equals, I got 64.9. 0.9 seconds. All right, so that means that if I walk 50 meters, it's gonna take me 64.9 seconds. Okay, all right. Displacement is the shortest straight line distance between 2 points in a specific direction. What does that mean? Let's walk over here, back to our course. All right, so before we started here, we measured the distance. We kind of changed directions a few times and we ended over there. We are still gonna end over over there this time. However, this time we're working on displacement, which is the shortest straight distance between 2 points. So here to here, as opposed from here to there. All right, so let me get set up here. Okay, so it clicks right there. All right, right? 1, 2, 3, 4. That was 4 meters. Go ahead and write that down right here. All right, so 4 meters. Let's get that down. All right, so displacement is how far and in what direction. So straight line motion, positions x in one dimension are described as points on a number line. So let's take a look at this. So I walked this way for 4 meters, okay, and I got 4 meters. What would be the difference if I walked this way for the exact same amount of distance? Boom, right there, 4 meters. What's the difference? Well, we're talking about a number line here, and as we go from here to here, from that to that direction, this direction is positive. And as I walk from there to there, this direction is negative. So, direction on a number line is either positive or negative. Definition of displacement. The change of position is called displacement. Over here we have this triangle thing in x. This triangle means, the word for it is delta x, but it really means the change in x. And x is just like the x-axis on the number line. It's your position. Position. All right, so then we have 2 different ways of writing these words in equation form. So again, delta x, the change in position, equals x2 minus x1. Or delta x, the change in position, is x final minus x original. These 2 mean the same thing. These 2 mean the same thing. So for example, if we went and took a look at, I'm gonna erase this real quick so I've got more room. What we did previously with this guy, okay? We know that I walked 4 meters. So I started at 1 point, 0, and I walked 4 meters. So my second x, I'm gonna say equals, my x2 was 4 meters. And my original, I started at what we're gonna call 0. So I'm gonna say 0 meters. 4 meters times 0 meters is 4 meters. All right, sweet. Okay, so again, we can do this the exact same way with final being this one and initial being that, all right? But what happened when I walked the other way. So my final distance in this case was actually 0 meters, right? I walked from that side to this side. And my initial, I started over on the 4 meters, so minus 4 meters. So over here, 0 minus 4 gets me a negative 4 meters. Now this makes sense because as I walked from left to right, it was in the positive direction. Okay, 4 meters, that's the number I get from my calculator, and it was in the positive direction and magnitude. As I come this way, I walk from 4 back to 0, and again, I get that number 4, but that negative sign tells me I was going in the negative direction. Okay. All right, I'm gonna ask you guys to do something for me. Take a leap of faith. Some of y'all might have seen this before. I'm gonna ask you to close your eyes. Open them. And the question is, what path did I take to get here? It doesn't actually matter. Well, it doesn't matter, because when we're talking about displacement, all is the distance it took to get from one place to the other. The path is irrelevant. All that matters is the distance from one point to the other. Let's do some practice. So the question is, what is the net displacement? So again, delta x is my net displacement. So I've got x2 minus x1 is going to get me my answer. So x2 is negative 1.5, and I subtract a negative, forgot my units, meters, and I subtract 5 meters there. Let me go ahead and plug that into my calculator. So I've got negative 1.5, negative 1.5 minus a negative 5. That gives me 3.5 meters. Okay, so that's my net displacement for this one. Now down here, I have x initial and x final. So I'm not going to use 2 and 1. Instead, I'm going to use x final minus x initial. Again, same thing, but just different format. So my x final is negative 32 centimeters. This time we've got centimeters. We subtract my x initial, which is 75 centimeters. Okay, so then I'm going to plug that into my calculator. Negative 32 minus 75, and I get negative 107 centimeters. Oh, done. Distance and speed have magnitude only and are called scalar quantities. When calculating speed or distance using the equation s equals d over t, you do not need to know the direction. Therefore, it is a scalar quantity. To think about this, think about when you're driving your car. If you want to know the speed that you are driving your car, all that you need to know is the distance that you're driving and how much time it takes you to cover that distance. You do not need to know the direction to calculate the speed. A quantity that has both magnitude and direction is called a vector quantity. Velocity is the rate of change of position. Here's our equation. V stands for velocity. This is displacement, which we have calculated, and this is the change in time. So we know before that we calculated this as a positive 4 meters. So I'm going to come over here. I'm going to put a plus sign right here because it is a vector quantity. It has a magnitude and a direction, positive. Now as I go back over here, I wanted to divide it by the change in time. So it took me 14.2 seconds. So I divide it by 14.2 seconds. And this is going to get me velocity. When I plug this into my calculator, I get 4 divided by 14.2, and I get 0.28 meters divided by seconds. This is the velocity.